Hey, what's up, guys? This is Chung. So this time, number 1734, decode XORed permutation. So this one is very interesting. Bit manipulation problem. Okay, so you're given like an integer array, a permutation. That is a permutation of the first n positive number, n positive integers, where n is always odd. So keep in mind, so n is always odd because we need this characteristic to help us solve this problem. So which means that, the permutation, which means that it's like a 1 to n, right? 1 to n, there's a permutation. The sequence could be, the order could be different. And then, you know, it was encoded into another integer array, encoded of length n minus 1. So the rule to encode is like this. So for the encoded I, the value will be the permutation of I XOR permutation I plus 1. So for example, if the permutation is 1, 3, 2, then the encode is 2 because the first one is a 1 XOR 3, and then the second one is a 3 XOR 2. That's how we get this 2, 1 here. And and then you're given like the encoded array, and then you need to return, you need to revert, you need to decode this array to its original value. And it's guaranteed that the answers always exist and unique. So the first one, we already given that. So we have encoded 3, 1, and then we are expecting to output 1, 2, 3. Yeah, this 3, 1. So, and for the second one is like this. So the encoded is like this, and we need to get this value. And there's some like constraints here. Cool. And so at the first glance, right? So we have no clue how we can revert this encoded. Basically, how can we decode this encoded string to its original values? So what we should do is that we should at least try some examples, and let's try let's try this. Let's try there. For example, if we have like this one, have 4 uh 2 4 uh 1 5 3 7 and 6, and let's say this is the original value. And so for the encoded string, what will the encoded string look like? So first one is the 2x or 4. Second one is 4x or 1, and then 1x or 5, 5x or 3, and then 3x or 7. The last one is 7x or 6. So I think most of you know that, if we XOR two values, the same values, it will be 0, right? So if we XOR 4 with 4, the value is 0. So if you only look at this XORed this value here, and you can find some patterns here, right? So let's say if we XOR everything, so it's going to be so this two fours will be canceled out, this two ones will be canceled out, this 2 5, 2 3, 2 7, and in the end it's actually the 2 XOR 6, right? But this still doesn't help us to solve this problem because we don't know 6 and we don't know 2. We still cannot get the original value. So I mean, let's say we have a x or b equals to x. So if we want to get either a or b, we have to know the value of a or b, right? So that we can do the calculation afterwards. Otherwise, if we don't know a or b, there's no way we can figure out the value of a or b. So by looking at this one, it won't help us to to calculate that. So here comes the tricky part. And if you look at the this values, right, like by some one the other instead of a consecutive ones, you will find a pattern. So let's say if we find if we only look at the even either the even element or the odd element, so what can we find out? Let's say if we only took at like the even element, we have 2 4, right? 2 4, this is the one, and then we have 1 5 and 3 7. So what numbers do we have? We have 2 4 1 7 3 3 7 2 4 1 5 and 3 7. If we compare with the original array here, so basically we're having everything except for the last one. Similarly for the odd one, so if we look at the 4 1 5 3 and 7 6, similarly, right, we have 4 1 5 3 and 5 3 and 7 6. The only thing that we don't have is 2. Then they give us like a very clear hint, right? Let's say if we take the odd element here, right? We have this one, and this one, and if we XOR, if we do a XOR of this element, and then we do a XOR, and then we XOR another one with a total XOR of this one of the original list here. So what we'll have? We'll have 2. We'll get 2 because 4 and 4 will cancel out 1 5 3 5 3 7 6. If we XOR everything, they will all be canceled out except for the 2. So if we do it that way, then we will get the first element of the original array, which is 2. As long as we have one element from the original uh, array here, we can just use that one to deduce, right? To deduce the remaining numbers. So how can we do that? Okay, so we know this one here, right? So we know this is like 2x or 4. We know this one, let's say for example, this one is x because that's going to be the first element of the encoded array here. And we know 2. So what do we have? We have 2 uh, x or b, right? Equals to x. And we're trying to calculate the b here. And we already know 2 and x. So how can we calculate b? Similarly, right, we can use the same uh, uh, characteristics of the XOR, right? We can do a XOR of 2 on both sides. So which means we're gonna do a XOR uh, XOR 2 on the left side, and we also do a XOR 2 on the right side. Since we have 2 and 2, so 2 and 2 will be canceled out. And the only thing left on the left is b. And x is already known. So the result will be x do a XOR of 2. That's going to be the value of b. And right, so similarly, if we already know the b here, which is 4, right, and we already know the 4 XOR 1, we can use the same formula to calculate 1, 5, 3, and so on and so forth. And we can deduce everything from there. Yeah, I think that's the basic logic here. And so here, the reason we need to use a odd, we we need to make sure the n is odd is because, let's say the n is even, which means that let's say the six is not there. So we have 6 numbers, and which means that the last one is not there. So if the n is even, then our solution will not work because if you only look at the even element, we have 4 1 5 3. But what's left? 2, right? 2 and 7. So if we use the same formulas, so we'll end up getting the XOR of 2 and 7 instead of the 2 itself, so which will not help us solve this problem. That's why the n has to be even. Sorry, the n has to be odd, so that we can use that either the odd items or the even items to help us get either the first element or the last element, and from there we can just use the decoded array plus the known numbers to calculate the rest of the numbers. Cool. So let's start coding then. And let's see, we have n uh, encoded. So I'm using this one encoded to get n here. So let's say we have. So first, let's calculate the XOR from 1 to n. Sorry, from 1 to uh, it's going to be a n, length of encoded plus 1 because the encoded is n minus 1. So the n should be uh, length of this one plus 1. So let's calculate that one first. And let's see, I'm going to call it XOR 1. How about that? So we have XOR 1 equals starting from 0, and then we do I in range of 1 to n plus 1, right? And then we have XOR 1, we do a XOR of everything from I. That's how we calculate the XOR from 1 to n. So, and we call it XOR 1. And then for the XOR 2, right? XOR 2, we have also starting from 0, but this time, like I said, since we're only considering the odd index so that we can get the first element. So we start from 1 and then uh, we end up with n minus 1, right? And then the jump is 2. So we have a XOR 2 is this dot gonna be the encoded I. Okay, so that's this is the even or the the odd index element, the total XOR of that. And then we can get our first element, which is the answer dot append x or 1 and then x or 2. So after this one, we will have our first element calculated. Then from there onwards, we can just do the rest, right? So we start from the first one, we end up with n minus 1. And then the answer will be append dot like I said, right? So it's always going to be the encoded of the encoded current element to an XOR of the previously calculated result, which is answer dot minus 1, right? And then in the end, we simply return the answer. Mm, yeah, I think that's it, right? So this part again, right? So this is we have the current encoded one, and then we do XOR of the previous one, then it will give us the next number. Okay, so let's run the code. Oh, okay. We haven't defined the answer yet. So the answer will be an array here. Okay, accept it. All right, cool. Yeah, so I mean, time and space complexity is, I think it's pretty straightforward, right? So it's only one single for loop, so it's like a n O of n time complexity, right? And space, space, I think it's probably still O of n since we're using like the answer to store the final result. Yeah, I think that's it. I mean, this one is, I think it's pretty interesting because this one requires you have like some tricky observations so that you can use the original permutations from 1 to n, then to calculate either the first element or the second element by only picking the either the even index or the odd index items, and from there, right? As long as we have one uh, calculate known numbers, we can just use this like a x or b equals x. If a and b if a and x they're both known, then we can do a like xa x or a on both sides to calculate to get the value of B. And that's exactly what we're doing here. Yep, pretty interesting bit manipulation problem, and I hope you guys like this video, and thank you for watching it, and stay tuned. See you guys soon. Bye bye.